Okay, in this question, we've got a function, and they say there's three important intervals. A and B are critical numbers. Critical numbers. So how do we find critical numbers? There are places where the derivative is zero or infinity. So if I take the derivative of this function, the derivative right here, bring down the 3, it'd be minus 6x squared, bring down the 2, plus what's that, 48x, and bring down the 1. Minus 72, then you subtract 1, so that's gone. And the 2 is just gone. So there's the derivative. Now, we want to find out where it's 0 or infinity. So what we can do is factor out a minus 6. This will be plus 12 and set it equal to 0. You double check that's right because that'd be minus 6x squared. Minus times minus is 6 times 8 plus 48, and minus times plus is minus 72. Just use your calculator if you're not sure about some of those numbers, and then keep factoring. Remember, we do FOIL now, F-O-I-L, front times front to make front, that's x times x. And last in this parenthesis times last in that parenthesis to make 12. Well, it could be 4 times 3, 2 times 6. It's going to be 2 times 6, so we've got to make that 8 in the middle. Both negative, because negative 2 and negative 6 make negative 8, and they multiply to be plus 12. Okay? What do you do from here? You just set the x minus 2 to 0 and the x minus 6 to 0. What about the negative 6? He doesn't matter because logically that's like saying, what if I had minus 6 times a number equals 0? That's what this is saying. Because minus 6 is just minus 6. He doesn't have an x. He can't vary. Doesn't have a variable. He's only minus 6. Whereas the other two parts have x's, so they can vary. So they could be different things. So really what this statement here is saying is it's just like if I said to you, hey, minus 6 times something equals 0. What does that mean? This one could be 0 or that one could be 0. To make them all multiply to be 0, it has nothing to do with the negative 6. So we just set that one and that one to 0. And then you know how to solve that. Just bump it over, bump it over. Plus 2, plus 6. So there we go. 2 and 6. Got to put them in order. A comes before B. There's our two critical values. Now, I want to determine if it's increasing or decreasing. What tells us that? Well, you know that f prime positive is increasing, f prime negative is decreasing. So we got to do like a number line thing here for that first derivative. We'd take the 2 and the 6 and put them on there. So I'll say okie dokie, about right here and right there. Good enough spacing. So x is 2, x is 6. This is from negative infinity, and this will be positive infinity. We're going to check the three intervals. I'll check something in this interval, like what, 0? Check x equals just to check that interval. Something in this interval would be like x is 3. You do 4 or 5, whatever. Something in this interval is x is 7, 8, 9, 10, up to 10 million. All right, check what? Check the first derivative because we want to know where it's increasing or decreasing. So let's take a look. Where's that first derivative increasing here? So what's the first derivative again? Right here. So the first derivative is minus 6x squared plus 42x minus 72. I'm going to take 0, plug it in, plug it in. Okay, let's do it. So I'll go to Desmos. Um, oh, here I plugged in 1, but let's plug in 0. Uh, 0, there we go. What do we get? Negative 72. That's easy. Probably could have done that without a calculator, huh? So f prime is negative 72. That means it's decreasing, going down in that section, huh? F prime in the middle, going to plug in 3. Go back and put in 3. What are we going to get when we put in 3? So put in 3. We're going to get 18. So that comes out positive 18. That means it's increasing in that section. Finally, going to plug in 7. Let's go back and plug in 7. So 7, 7, I get negative 30. And so that's negative 30. Means it's decreasing. in that section. So they want to know what are the interval? Yeah, the first interval, negative infinity up to A. This is A. I'll put down the A and B. This is A here. This is B here. So from negative infinity up to A, it's decreasing, and it's increasing in the next section, and it's decreasing in the last section. Okay, now they want us to conclude. So where are the local maxes and mins? Well, now you can see what's happening. So the function's going down here, up here, and then down there. So this point here, A must be a minimum, and this point here, B must be a maximum, huh? So A is a min, B is a max. And there we go.